Hey everyone, first of all, I apologize, my AirPods died, so the volume might not be as good today, but hopefully this is still helpful. So we're going to do an example today where we have a graph and we're asked to state the domain and the range of our function f of x. F of x acts like our second variable y, our independent variable being x, and we're going to find f of 1, namely the function when x is taking on the value of 1. And then finally, we're going to find the value of x when the function f of x is itself at a value of 0. So essentially when y has a value of 0. Okay? So the first part, let's start off with our domain. Again, our domain is the set of values that are independent variable, in this example, that x can take on. It's essentially identifying what restrictions we have on our variable x. Now, in this case, we have what's called a parabola here for our graph. So we see that the function extends by the arrow depicted in the graph, extends infinitely in both directions, right? It would go, if we drew the entire graph, if we drew it big enough, it would go infinitely far in the positive x direction and the same thing in the negative x direction. So there are no restrictions on the x values that our graph can be drawn for, that the function can be evaluated for. And so in this case, since there are no restrictions, all we have to write is inside of a set, try to make this look nice, we write that x can be any element of the set of real numbers with no further restrictions, okay? Again, this is a set of all possible values, and so we write them inside of these squiggly looking things, okay? And separately, the range of our function is the possible y values of our function, right? And so if we look at our graph, what are all of the possible y values that we might have somewhere, anywhere on our curve? Well, since the arrows extend infinitely up and out, there is no conceivable upper limit to the y values, which means the values that f of x can take on. So there's no upper limit, y can get infinitely big, but there is a lower limit, right? Down here at what's called the vertex that you'll see later on, the y value, or the value of f of x, since they're really the same, just written in different notation, is negative 3.25, right? That's the lowest possible value that y, or that f of x, can take on in this function. And so that's going to be our lower limit. So our range is going to be y being any element of the real numbers, such that y can be any element of the real numbers, right? Any decimal, any whole number, any rational number, any fraction, any real number, so long as it's greater or equal to the lowest possible value, right? It can't be less than, it can't be lower than negative 3.25, and so mathematically we write that as y being greater or equal to negative 3.25. Again, using nice set notation, because this is a set of all possible values of y, okay? B and C are a little bit quicker to find. Find f of 1 means f evaluated at 1, i.e. when x, the value inside of the bracket, is 1. So when x is 1, we can just look at our graph for that, right? When x is 1, that's here. F of x, again, f of x is the y coordinate at each point, so that's around here, right? So that looks pretty close to negative 2. So I'll say, by looking at the graph, f of 1 is negative 2. You can maybe argue negative 2.1, something like that. Sorry, this should be, that's before drawing the graph. That's negative 2.25, which would make this negative 2.25. I'm so sorry about that. Please bear with me here. But with that taken care of, we see that, again, f of 1, which is the function evaluated when x is equal to 1, we drop down to the point that's actually on the curve of the function that we have as a graph, and we look at the y coordinate, right? The coordinates of this point here would be roughly 1 for x, negative 2 for y, and so we say f of 1 is equal to negative 2, okay? And then, kind of the opposite, find x when f of x is equal to 0. So when f of x, which is to say when y is equal to 0. Again, we can read that off the graph pretty quickly. F of x is 0 here when x is 3, and also here when x is negative 2. So x is equal to negative 2, or x is equal to 3 would suffice for our solution. So again, I hope this helps. Just a reminder to always write your domain and range in set notation, because these are sets of all possible values that x and y can take on respectively. F of 1 means the function evaluated at 1, which is oftentimes analogous to saying the y coordinate when x is equal to 1. And then C is just kind of the inverse of B, okay? Hope this helps. Please leave a message if you have any questions, comments, suggestions, and have a good day.